Have you ever wondered what makes modern buildings, bridges, and massive infrastructure stand strong for decades? The secret lies in a gray powder that transformed construction forever: Portland cement. From towering skyscrapers to highways and dams, this material forms the backbone of modern civil engineering. But what exactly is Portland cement? How does it work? And why is it so essential in construction? Let's uncover the science behind this remarkable engineering material. In today's video, we will explore one of the most important materials in the construction industry: Portland cement. We will discuss its composition, the chemical processes of setting and hardening, different types available, and its practical uses in engineering projects. So let's begin our journey into the material that literally holds our modern world together. Portland cement is one of the most widely used construction materials in the world and serves as the primary binding ingredient in concrete and mortar. It is a hydraulic cement, meaning it reacts chemically with water to form a hard, solid mass that gains strength over time. This unique property makes Portland cement ideal for structural construction. The name Portland cement was first introduced in 1824 by Joseph Aspdin, an English mason, because the hardened cement resembled the color and quality of Portland stone found on the Isle of Portland in England. Portland cement is manufactured through a controlled process involving the grinding and heating of raw materials such as limestone, clay, and shale. These materials are first crushed and mixed in proper proportions before being heated in a rotary kiln at temperatures around 1,450 degrees Celsius. At this high temperature, the materials chemically react to form clinker, small nodules that contain essential cement compounds. The clinker is then cooled and ground into a fine powder along with a small amount of gypsum. Gypsum plays an important role in controlling the setting time of cement. The final product is the gray powder we know as Portland cement, which becomes the key ingredient in producing concrete, the most widely used construction material on Earth. Composition of Portland cement. The performance and strength of Portland cement depend largely on its chemical composition. The main raw materials used in its production are limestone, which provides calcium oxide, and clay or shale, which supply silica, alumina, and iron oxide. The four primary compounds that form during the cement manufacturing process are trichalcium silicate CYS. This compound is responsible for early strength development in cement. It reacts rapidly with water and contributes significantly to the initial hardening process. Decalcium silicate CS. This compound hydrates more slowly and contributes to the long-term strength of concrete. Trichalcium aluminate CYA. This compound reacts very quickly with water and is responsible for the initial setting reaction. However, it can also make cement vulnerable to sulfate attack. Tetracalcium aluminoferrite CGAF. This compound mainly influences the color of cement and contributes moderately to strength development. The proper balance of these compounds ensures that cement develops strength, durability, and stability suitable for structural construction. Setting and hardening of Portland cement. The setting and hardening of Portland cement occur through a complex chemical process known as hydration. When water is added to cement, a series of chemical reactions begin between the cement compounds and water molecules. During the initial stage, trichalcium aluminate reacts rapidly with water, producing heat and causing the cement paste to start losing its plasticity. This phase is known as the initial setting stage. Next, trichalcium silicate reacts with water to form calcium silicate hydrate, commonly called CSH gel. This gel is the main compound responsible for strength development in cement paste and concrete. As time progresses, decalcium silicate continues reacting slowly with water, contributing to the long-term strength and durability of the hardened material. The hardening process can continue for months or even years as hydration reactions gradually fill microscopic pores within the concrete matrix. This is why concrete structures gain strength over time and become increasingly durable. Types of Portland cement. Portland cement is available in several types, each designed to meet specific engineering requirements and environmental conditions. These variations are standardized under various national and international codes. Ordinary Portland cement OPC is the most commonly used type and is suitable for general construction such as buildings, pavements, and bridges. Rapid hardening cement is designed to gain strength more quickly than ordinary cement, making it ideal for road repairs and precast concrete work. Low-heat cement is used in massive concrete structures like dams and large foundations where excessive heat generation could cause cracking. Sulfate-resistant cement contains a lower percentage of trichalcium aluminate, making it suitable for structures exposed to sulfate-rich soil or groundwater. White Portland cement is produced with low iron content and is mainly used for architectural finishes and decorative concrete. Each type is engineered to provide specific performance characteristics depending on the requirements of the project. Uses of Portland cement. Portland cement plays a crucial role in modern construction and infrastructure development. It is primarily used as the binding material in concrete, mortar, and plaster. In structural engineering, Portland cement is used in the construction of buildings, bridges, highways, dams, tunnels, and marine structures. When mixed with aggregates and water, it forms concrete capable of withstanding heavy loads and environmental stresses. It is also widely used for masonry work, flooring, plastering, precast elements, and reinforced concrete structures. In addition, Portland cement is essential for infrastructure projects such as airports, railways, and irrigation systems. Because of its strength, durability, and versatility, Portland cement remains one of the most indispensable materials in civil engineering. Understanding Portland cement is fundamental for every civil engineer because it forms the backbone of modern construction. From its chemical composition to its role in structural strength, this material is essential in almost every project we build. If you enjoyed this engineering explanation, subscribe to Civil Engineering Edge for more in-depth civil engineering concepts and practical construction knowledge.